3 series lecture, we covered the basic fundamentals of speech recognition or signal processing using LabVIEW. In the second episode, we talked about various functions and methodologies that you can use for signal processing in LabVIEW. And as guaranteed, in the third episode, I'll be showing you a speech recognition VI in which I'll be speaking out words and the VI will be able to identify those words. We will also be discussing the algorithm that was used behind that VI, and after that we'll be discussing a few CLAD, which is Certified LabVIEW Associate Developer Exams sample questions. To interact with us, you can ask your questions to our technical consultants in the questions window, or for real-time chats, you can ask your questions or you can start your discussions in the chat window. There are two ways to listen to us. First one is VoIP, which is voice over IP. To use voice over IP option to listen to us, you just need to turn up the volume of your computer to listen to us. You can also dial, if you have a slower internet connection, you can also dial a number 1-800-425-4061, which is a toll-free number, followed by the pin 779139# to connect to us if you're calling from India. If you're calling from outside India, you can dial the number 9144-2370-2370, followed by the pin 779139#. Typically, for any signal processing application, there are three main stages: acquire, analyze, and present. In acquire stage, the signal coming from any kind of sensor or saved file is acquired into LabVIEW, and it is presented or pre-processed to make it usable for further processing. In analyze phase, signal processing algorithms are implemented on the incoming signals to extract useful parameters from it. In present phase, the data is presented in a way that is most suitable for the users to understand. In this particular application, we acquire the sound using external microphone for the duration of 2 to 4 seconds with resolution of 16 bits and a sampling rate of 20 kHz. The pre-processing that was used here involved steps like filtering the signal, making it appropriate for the consequent steps, as the signal as it is not suitable for any analysis. In pre-processing, filtering was used to compensate the suppression of high frequency part in the voice production mechanism of humans. We use a high pass FIR filter to increase the magnitude of high frequencies with respect to other frequencies, hence improving the signal to noise ratio. In framing, framing is used to detect the dynamic changes in the speech signal. It is necessary to analyze the signal in short intervals. So we divide the waveform into small frames of 15 to 30 milliseconds each, and these frames are put into analysis separately. To get rid of unwanted noise, we set a threshold limit for the signal energy, where the energy is directly proportional to amplitude square. The start and end time detection is used to calculate the exact time when the voice command starts and ends, so as to filter the signal further. A Boolean array and median approach may be used to enable start and end time detection. In the analysis phase, most important phase was parameters extraction. Parameters like MFCC or delta or acceleration were extracted from the data. MFCC stands for Mel Frequency Substrum Coefficients. Humans have high frequency resolution at low frequency and low frequency resolutions at high frequencies. MFCC stands for cosine transform of log of Mel spectrum coefficients, where the Mel spectrum coefficients are equal to windowing coefficients into power spectrum coefficients, where windowing coefficients account for the non-linear frequency resolutions of human ear. To capture the dynamic changes in the MFCCs of the voice signals, we calculate delta and acceleration coefficients. Delta is the first derivative of MFCC coefficients and acceleration is the second derivative of MFCCs. The above parameters are then fed into a 2D array so as to compare them with the reference already set in the same fashion. To improve the reliability of the recognition system, 4 to 6 sets of such voice commands are stored in database as a reference. To compare the sequences, we use the dynamic time warping for time per speed varying sequences, or Needleman-Wunsch algorithm, Smith-Waterman algorithm, etc. to characterize or figure out what was the word or what was the command that was given in the voice. Presentation of this data can be done in any required format. Let us say you could have a few LEDs onto the front panel, or you could have a text indicator onto the front panel of your LabVIEW VI, or you could actually take actions such as start the motor or stop the motor based on the voice commands that you give. Applications of this VI are for you to ponder and explore. For example, building a speech control devices or equipments similar to a wheelchair or a robot, etc. Let me now demonstrate the VI that has been developed. Now, this is the front panel of my VI, on which you can clearly see that I have 4 LEDs: forward, left, backward and right. Now as soon as I run the VI, whenever I speak forward, the forward LED is supposed to glow. Whenever I speak right, the right LED is supposed to glow. And the right commands will also get displayed into the string indicator. Let us see how it works. Forward. It needs to be tuned. Please give me a minute. It is working now. Forward, backward, right, backward, right, left, forward. And when I make any other noise other than these 4 commands, you can say that in the command window no command is displayed. But when I say any word, let us say backward, it certainly displays and identifies the word. Let us now have a brief look at its block diagram. So, a block diagram as small as this was used to develop such a big application. So you can see that here there is a pre-processing sub-VI, then there is a parameters sub-VI, and there is a comparison sub-VI as mentioned in the application. I hope this demonstration and algorithm discussion will help you develop your own VI on sound processing. Let us now go and solve a few CLAD sample questions. As many of you might be wondering when you could go ahead and solve those sample questions. So here I have created a few polls. So I'll show you the question in front of you with the answers for a few seconds, let us say a minute or 50 seconds. After those 50 seconds, I'll be releasing a poll. And once the poll is released, you will just have to give the answer into that poll and click OK. The poll will be active for approximately 20 seconds, and after those 20 seconds, you will be able to see your next question. So in this question, they are asking what is the result in array after the following code has executed. So in this code, we can clearly see that there is a nested for loop with 2 indexed tunnels. The innermost function which has been used here is a random number generator function. This function gives out random numbers, and those random numbers are then stored inside a single dimension array in the inner for loop, and the outer for loop is responsible for the second dimension of that array. The question will be visible for 15 more seconds. I'm launching the poll now. I see there's a lot of confusion in the options B and C. Almost 65% of all the audience have voted already, 67% now. Let me wait till it goes to 75%. You have 5 more seconds to vote. All right, I'm closing the vote now. And the right answer is B. because the innermost for loop will be responsible for the row dimension or the lowest dimension, and the outermost for loop will be responsible for higher order dimensions. The next question is related to the design patterns. They're asking, the following figure is an example of which common type of VI architecture? The options are parallel loop VI, multiple case structure VI, state machine VI, general VI. In this particular VI, we can clearly see that there is a while loop with a case structure inside. The case structure has a case selector terminal, which is nothing but an enum. And inside the case structure, we have the cases which determine which case should be executed or which state should be executed in the next iteration of the while loop. In next 15 seconds, I'll be launching the poll. So please be ready with your answers. The poll has been launched. The poll will be active for next 10 seconds. I'll repeat the options for those who have not noted down the options. Option A is parallel loop VI. Option B is multiple case structure VI. Option C is state machine VI. And option D is general VI. I'm closing the poll now. And the answer to this question is state machine VI, which is option C. So in this particular VI, we can see that there is a while loop and there is a case structure inside while loop. And inside every case, there is a case selector terminals next state that has been defined. Next question. Which of the following statements is not true regarding the figure below? In this figure, we can see that there is a for loop with a multiplication box inside. There's an input array and output array of one-dimensional elements. Let us now go through the options one by one. Option A states that it is not necessary to wire the count terminal because auto-indexing is enabled. Option B, elements of input array enter the loop one at a time. Option C, output array is the same size as input array. Option D, if you disable auto indexing on the right side of the for loop, the output is still a 1D array. Option E, all of the above statements are true. I'll be launching the poll in 15 seconds. So please be ready with your answers. The poll has been launched. I'm closing the poll in 20 seconds. And the answer for this question is option D, which is if you disable auto-indexing on the right side of the for loop, the output is still a 1D array, which is a false statement. Because if you disable the auto-indexing on the right side of the for loop, the output will be a single element of double data type. Let us now have a look at this question. Which answer matches the correct labels with their corresponding legend or palette on the following front panel? Let us go one by one. Option A is where A is cursor legend, B is graph palette, C is plot legend, and D is scale legend. Similarly, there are B, C, and D options given. Please go through all the options and all the red markers and determine the right combination of markers and options. I'll be launching the poll in 15 seconds. I'm launching the poll in 5 seconds. The poll has been launched. In another 5 seconds, the poll will be closed. And the answer to this question is option B, where A is lot legend, B is graph palette, C is scale legend, D is cursor legend. Let us now go to the 5th question. Which of the following statements is true regarding the figure below? A. Auto indexing is disabled. Only the 10th value generated is passed out of for loop. The output for the for loop is the 1D array of 10 elements, both A and B and both A and C. I'll be launching the poll in another 10 seconds. The poll has been launched. The poll will be closed in another 5 seconds. And answer to this question is option C. The output of the for loop is a 1D array of 10 elements. As the auto indexing is enabled on the output side of your tunnel, the output of the for loop will be a 1D array of 10 elements. Next question is a fill in the blanks question. The blank determines the total number of times a for loop will execute, and the blank returns the number of times the for loop has executed -1. Option 1, count terminal and condition terminal. Option 2, count terminal and iteration terminal. Option C, iteration terminal and count terminal. Option D, conditional terminal and count terminal. I'll be launching the poll in 5 seconds. The poll has been launched. The poll will be closed in another 10 seconds. And the answer to this question is option B, which is count terminal and iteration terminal. The next question, what is the value in K after the following code has executed? So in this code, you should be able to use the data flow model of programming to calculate the value of K. The poll will be launched in another 15 seconds. I'm launching the poll now. The poll will be closed in another 5 seconds. And the correct answer to this question is 200, which is option C. And the last question of the day, what is the result in output array after the following code has executed? I will be launching the code poll in another 15 seconds. I'll be closing the poll in another 5 seconds. And answer to this question is option A. I see that many of you have given wrong answers for this question, so let me explain this to you. The build array function then takes input of two arrays of different sizes, takes in the array with the maximum length of elements. Let us say in this case we have two arrays as input to build array function. One of the arrays has 3 elements and the second array has 2 elements. So the output of build array function is going to be an array of 2 rows and 3 columns. It will take the maximum dimension of array and it will pad the smaller array with zeros. So the output of build array function will be an array of element 251 in the first row and 430 in the second row. When this 2D array goes to the index array function, the indexed array or the indexed dimension is the second row. Number 1 signifies or refers to the second row. So the output of index array function is going to be the second row of the output of build array function, which is going to be 4, 3 and 0. So this was the last question of today. This week's contest of the week is also going to be dependent on the CLAD questions. extend your Webcast Wednesday learning experience on LabVIEW enabled, the NI India online community. The NI India community is a single network of students, industry professionals, and academicians collaborating and coming together to create discussions, exchange and share resources, generate content on applications, NI technologies, as well as the industry trends and other third-party technologies. It serves to unite users not only from India but also from across the world on collaborating on similar applications. Simply put, it's a social network for engineers, students, and researchers. Apart from the live online interaction during the webcast, an extended discussion and content on the topic will be carried out for an entire week by the presenter on LabVIEW enabled. Watch the previous episodes of Webcast Wednesday, get your queries from the sessions and LabVIEW resolved, and participate in weekly contests to win up to 50% discount on National Instruments certification examinations. You can attend 20 sessions to win a free CLAD attempt. You can watch the recording of this session and participate in the contest of the week when you visit www.labviewenabled.in.